Going to explain what I did there on the class. It seems to be working, but I didn't. I just tested the simplest case possible. So I'm probably gonna, because in order to test other more complex cases, I have to fix the headless code. So I'm going to explain what I did so far, the class, then change some small things before, and then I'm going to work on the headless code that I have there. So just explain what I have, then I'm probably gonna, I just realized that I have to move the class from the folder that I put the class on to another folder. Then after I do that, I'm going to work on the headless code and then probably test more complex cases for the class. And also, I'm pretty sure that there are other ways to create to save the state of the signal there, but I think I'm just gonna leave it the way that it is because it seems to be working. And there are two different ways there that I found, but the one that I'm implementing now is the easiest one that I think, and is probably better than the other way, but I'm just gonna leave the other way as well there. And I'm gonna explain because there's also another different way to do it than the way that I'm doing now, but it's basically the same thing, just a small change. But I think I'm going to leave in the way that I have there. So probably should explain so I think I'm gonna explain from the beginning, for someone that doesn't understand anything. So in Godot, you have this concept called signal, which is, if you understand web development, is basically the same thing as an event. It's very similar. So it allows you to connect the functionality of two different nodes. So usually the way that people do it is from the editor, which is the application here. And the way that the people recommend you to do it is by using GDScript language, which is something that Godot developers created to make it easier to encode functionality on nodes of the scene. So a scene is just a tree, and then each node is going to have a behavior, which is the logic of the class that makes up the node. And then if you like, the most common example is if you have a button, for example, and you want something to happen after you press the button, after someone clicks the button, then the way you achieve this is by using a signal. So the moment that they press the button, you put whatever functionality you want from another class, which would be another node from the scene, so that the node does whatever you want. And the way you do it normally, that I've seen from other tutorials, is you create a GDScript file, you attach that GDScript file to a node, and then inside of the function of the GDScript file, you would put the code to connect the signal. Or the other way that I've seen is that select the node from here, then you go to here, and then this is like basically the list of signals that each class has. The class here represents the class hierarchy from the node that you selected here. So the base class of this node would be the object here, and then the actual class is this one. So it's basically representing the class hierarchy. So each class on the class hierarchy has its own signals, and then you would choose the one you want to put functionality, then you click on connect, and then here you would need to have a GDScript file that it would allow you to select what function is going to run after the event's emitted. And the emission of the event always happens from the same class that connected to the event in the first place. So in this case here, for example, focus entered. The class that connects to the focus enter is the control class, which spin slider inherits from. And if this class doesn't connect to the event before, then it can't emit the signal. You have to connect first from the class, then the same class emits the signal. And the way that the bridge is made is by the callback function that you subscribe to, which is normally going to be the function from another class, and that's what creates the bridge. So the control class emits the focus centered, and then you put whatever function from GDScript you would want to run after the event is triggered, is emitted, and then it allows you to encode whatever functionality you want. So the most normal use case is you have a parent node, and then the child node connects a signal and then calls a callback function from the parent. That allows you to like change, for example, a slider or something like that based on events that these control nodes emit. But so this is the way to do it on the GDScript from the editor. But if you want to do it from C++ code, it's basically the same thing because it's very similar because obviously the GDScript file is going to be parsed into C++ code, and the functionality is very similar. So on C++ code, all the classes have a function called, all the classes that inherit from object can declare and define a function called notification. And then on that notification, it allows you to run whatever functionality you want, depending on different parts of the cycle. So, and these parts are defined by the argument that the notification function receives, which is an enum. So the way that you declare is by specifying what kind of, you put the argument on one switch, and then you use one of these values of the enum here, which are specific for certain parts of the event. So as far as I understand now, the notification ready here would be equivalent to the underscore ready function on GDScript. So like it's a one-to-one relationship. The functions you have access to on GDScript are basically the same functions you have access on the notification, and they happen at the same time, depending on the name of the function, and they're declared on a macro, C++ macro inside of the class that is going to have those functions available, which is the node class. All the other objects, all the other nodes on the scene are probably going to inherit from node because the most base class is the object, then node inherits directly from object. So basically, all the nodes are going to inherit from node, the node class. The node class uses these macros to subscribe these functions from GDScript, which are equivalent to the notification function here, the events, because they happen at the same time. So the ready, for example, notification ready happens after the whole tree is initialized, and now the nodes are ready. And notification enter tree, obviously, for example, would happen after the node enters the tree. So you have several different spots here where you can define different behavior for the node, depending on what you want the node to do. And the way that the editor, for example, the editor node, which is the node that creates the whole layout and the whole GUI for the editor, the way that it works is that they connect the signals using the connect function, which is the actual C++ function that makes the signal connection happen. And they do that inside of the constructor of the editor node. Which is basically here. So when you're running the build that is going to run the editor, there's some conditions inside of the main setup function, which is the function that sets everything up before the rendering cycle begins, before the game loop starts. And then that function is going to initialize this node here, which is the parent node of the whole editor. So all the functionality that you see on the editor is going to happen inside of the constructor of this class. And here is where they basically create each GUI element that is going to show up there, and is where they do the connections of the events. So the way that you usually connect a signal is by calling the connect function on the signal. I'm just going to search for connect here. Maybe I can. Yeah, so it's basically this function here. This is equivalent to what they do in GDScript there, but it's on C++ code. So basically, this connect is going to connect this class here. So this class already connects to the... It's going to emit the timeout by default, because on the class hierarchy of this thing here, which is the timer class, there is one spot of the function, one of the functions is going to emit the signal, because otherwise there would be no point to connect. So that's usually the pattern. The class already is designed in such a way that it's going to emit the signal, And if you want a callback function to happen at the moment that the class emits the signal, you call connect on the same class that is going to emit the signal. And then you put this macro here, which is callable MP. Then you pass the instance of the class that is going to call the callback function. And you pass the address of the callback function, which is this one. When you're using this macro here, this macro is going to create a callable class, going to initialize a callable class, which is a class that basically is going to translate the state of these things here. It's going to save the state in a way that Godot later on can figure out what is the function and what are the arguments of the function. So that is able to call the callback function at that point the signal is emitted. So it's basically helper classes that help Godot keep track of the state of whatever you subscribed here. And there's different ways, but I'm not going to explain. But this is the one that is the most used. And in my case there, I'm using another one because I had to, and it's a lot easier to do it. But basically, this is like subscribing the callback function from that class to run whenever the signal is emitted. And this is the callable, and is initialized with this other callable here. And then it basically saves the information on the properties of this callable here, which is going to figure out by the point, once it emits the signal, what Godot is going to do is going to use another class which is called variant, which has a bunch of C++ functionality that allows the class to convert the standard types that they support that are on the variant. Which means that it doesn't matter what function you put as a callback, as long as the function has the same types as arguments as the signal emits. So for example, let's say the signal emits a float as one of the arguments. So it's going to emit the name, it's going to call emit signal and pass the name of the signal, and then the other arguments that it's going to pass are the arguments that the callback function needs to have or is going to receive from the signal. Because that way it allows you to transfer information. So for example, on the slider, you would put the value of slider, for example, so as an argument. So it's like 31 float. And the callback function would receive that as an argument. So the argument that the callback function that subscribes to the signal, it has to be the same type as the other one. And that translation is done with the variant class, because the variant class overloads constructors and operators. So it allows C++ to initialize and transfer the information based on the logic that they put on the variant class. So yeah, and the problem with this is that if you do it in the same way that the editor does here, what's going to happen is you're going to have access, even though you're creating the node from C++, you're still going to have access when the scene runs on the editor or as a game, because the functionality is being done inside of the constructor of the class. And the way that the editor is going to initialize the nodes and the way that the game is going to initialize the nodes based on the resource is going to be based on the scene files, which are the data that makes up the actual game or application. So the scene files are stored on the root of the projects you have. And what Godot is going to do, either for running a project or if you're running the project as a game directly without using the editor, or if you're running from the editor, running the project from the editor, is basically the same thing. It's going to use those resources to get the state of the thing. So here are the projects I have, for example, and then the scene files. The scene files are going to be on the root of the project. And what Godot does is store the state here. So it gets the state from the scene file, and then it's going to run, every time that it initializes a node, it's going to run its constructor. So this is the main thing that is the problem that I had, which is the signals are they're rebuilt on runtime. If you declare them or if you define them or make the function call inside of the constructor, because then Godot's going to run the constructor and then you're just going to define the signals on runtime. But if you want to put the signal outside of the constructor of the nodes, then it's not going to cache the signals on the scene file, because even though the signals are created on runtime, it doesn't save them on the file. So when you open the project on the editor or you try to run it as a game, it's not going to have the signals anymore, because the connection is being done outside of the constructors. And the reason why it makes sense to do this, as far as I can think about it right now, is that if you create a whole scene using the editor example here that they created, you won't be able to change the scene from the editor because you only have access to the node here. So for example, if I subscribe the editor node into the class DB, which is the way that you can expose the classes you create on Godot, so you're able to change them on the editor, you would only show editor node here as a node, and you wouldn't show any of the children that were added to the editor node, because the children are also added inside of the constructor. So if you want the nodes to show here, you have to add them as children outside of the constructor of the class. But if you do that, then you have the problem that the signals are not cached, so you can't restore the state. And I think I found probably the best way that I can think about it right now. I'm not 100% sure, like I said, if it's going to work for everything, but it seems to be working out for the simplest example as possible. So I'm going to test, like I said before. So after I explain this, I'm going to fix the other part of the headless code, and then I'm going to test different ways to connect signals to see if they still work. But basically the key here that I thought about is that, so basically I created this. There's another thing that you have to do. So I'm going to explain what you have to do if you want to add new nodes, your custom nodes to Godot, which is basically this class here that I created. And what you have to do is very simple. You just call the macro, is this macro here, gd register class. And what this macro is going to do is going to call a function from class DB, which is a class that they use to keep track of all the types on Godot, all the types that Godot supports. And if you're creating a module, is just going to be a folder inside of the modules folder. And there's stuff on the documentation that explains how to do it. But it's basically, that's all you're going to do. You are going to create a class, and then you put the class inside of this, put the class inside of this macro here. And inside of the class, you need to call another function called bind methods, which is going to allow you to register all the functions of the class, and also add property, which is another macro that allows you to subscribe the methods or the properties of the class into the class DB, which, like I said, is the same thing with the callable. Those are classes that allow Godot to keep track of the state of the class. So it's basically holding the information that makes up the class so that they are able to serialize the class. So pass write them to the files and load the state from the files. That's basically the purpose of these other classes, which are called method bind and method bind and class DB. Method bind is the class that is going to manage, and property info. So method bind is a class that manages the state for functions. Class DB is a class that manages state for classes, which uses method bind as well. And then property info is a class that manages the state for properties. And then both method bind and property info are used on class info, which is a class that is used inside of class DB to keep track of the class state and allow them to serialize the information. So read and write from the scene files. It's basically just calling this thing here, and this is going to make the class type be subscribed to on class DB. That's basically what's happening. So every time you create a new class, you have to subscribe, which is what I did here. And I was getting an error because this class inherits from node, and I was trying to register before I was registering node, because I put this class in the folder, the object folder. But now this is the thing that I said I have to do, to just transfer this class to the node folder. Because initially I thought that, because the signal functionality is declared and defined on the object file. So I thought it would make sense for this class to be declared and defined in the same place, but because this one inherits from node, because it is a node, it makes more sense to put it inside of the scene node file. So that's basically what I did here, just create this class. And whenever you want the class to be subscribed on class DB, you also have to put this macro here, which is gd class, which is going to basically copy and paste a bunch of functionality inside of this class here, which are also helper functions that allow Godot to subscribe the class on class DB, and also call the notification function, which is the function that I was talking about before, which is going to allow you to put functionality, to change the behavior of the class hierarchy on different parts of the cycle. So allows you to encode behavior, basically. And this get property list is the function that class.db uses to get all the properties from the class after you use the add property macro to subscribe the properties. So the main function is going to be this bind methods here. And this is basically the way to think about it is like you're subscribing the state of the class, whatever you want the editor and the game to have access to, in order to serialize the information, or like aka save the information into the scene file. So you're able to transfer and also use signals. So the other macro is add signal, which allows you to subscribe your own custom signals for the class. But yeah, I'm not using this one here. So basically, the only thing that is kind of tricky is that in order to be able to assign the property on add property, it needs to be supported by the variant class. So because the variant class is the one that is going to be used to translate the types. And is basically the main thing that allows Godot to do this transfer of state between classes, because the variant class is going to manage how the information is changed depending on the situation, because of the functionality that it has and the logic that it has that is going to allow it to store and manipulate the memory for each specific type. So this is the tricky part about this. And the other tricky part is that, so basically this is the main class that I created that it seems to be working to connect all the signals and also allow you to cache them on the sync file, because the state, the connection of the signals is made based on the state of the class, which is designed with the properties that are cached by Godot. So basically the signal connections are done indirectly, because the way that it works is that you're going to subscribe them based on the string names. This subscription is going to change the state of the signal serializer, and then based on an event that the class receives inside of the notification, is going to set up all the signals based on the strings that were subscribed, which are based on the property of the class. So it receives the signals as the string names. So here I'm receiving the source, which is the name of the class, the name of the node of the class that is going to subscribe the signal, that is going to connect to the signal. Then the signal name, the target node name, and the target function name, which is the callback function. So I basically use these 4 strings to store them in a way that is going to allow me to save them on the sync file with the properties, which is basically these dictionaries that are created. And here I had to put, and this is the part that I think that there might be, like there's probably other ways to do it that would make it easier to change the signals from the editor, but I'm not really sure if I'm going to do that. But basically, after you do this, so I'm going to explain this one, then I'll explain the rest. So basically here I create another dictionary, and this dictionary is going to keep track of the signal name to the callback function. So I have one unique dictionary for every connection you make. Then you have this other dictionary, which this one is saved on the state of the class, which is mapping basically the source to target connections. And you have this other which maps the signal to the function, the callback function. No, it maps the signal to the dictionary that contains the signal name to the function callback name. So this one is the main one that keeps track, because then you can use this dictionary here to figure out what is the connection. So which one is the source, which one is the target that's subscribed. And then for each one of these, you're gonna put the connections of the callbacks in a variant. So like you can have one target that connects multiple callback functions for multiple signals on the same source. So this is the reason why it has to be a vector of variance here, because each time that it connects, it's just going to push the new connection, which is this dictionary that keeps track of what signal was connected to and what is the callback function. So it's creating multiple different dictionaries for each connection, and it's storing them by linking them with the same source and target. So the source node is the main thing that is used to figure out what is the signal name and what is the function callback. And then based on the other dictionary, you're going to have the target because it maps the source to the target. Yeah, so the connection is this one basically is a dictionary of string name. String name is the source node. And this is going to be equal to a vector of a dictionary. But it has to be specified as a variant. Otherwise, Godot doesn't understand how to translate the information. So this is the downside of this approach. And this is why I'm saying that there's probably another way to do this. Because from the editor standpoint, if you put variant here, it's going to allow you to put any value that a variant supports, and this might break the thing. And you have to remember that it's a dictionary if you want to make it work, which is not very good, but it is working right now. So I might change this later, but for now I think that's fine. And then each dictionary inside of here is the mapping of the signal name to the function name. So this basically connects the signals. It changes the state of the class. And unsubscribe doesn't matter that much. And then the actual connection is going to happen. So like, and this is the good thing about this approach is that it doesn't require you to connect the signals at any specific time, because you only depend on the names of the target node, source node, and the signal and the function callback. So it allows you to set up the connections at any moment you want, but it has to be, all the connections have to be done before the tree is fully initialized, because the way that the signals connections are going to happen is after the notification ready function runs. So the way that's is going to work is that you're going to create this class here, and then you're going to put this class directly connected to the root of the scene, which means that once you add the class, so you add this class before any other node, and then right after you add the class, which is going to be on this event here, you update the root node of the class should be the owner, and the owner is going to be the root node of the scene. So this is going to allow you to have access to the owner of the scene. Then you connect the node removed from the tree, scene tree, which allows you to run a function every time a node is removed from the scene. And basically you want to check to see if there is a signal connection for the node, and if there is, you're going to disconnect the signal. So this is the function that does the disconnection. And then you run this function only one time once the tree is fully ready, which is going to be on the notification ready, which means that this function here is going to get the state of all the subscriptions you have based on this. And from that state, it's going to build all the connections at the same time. And because you're building the connections from the state of the class, then it means that as long as you have the state, Godot's going to be able to save and write to the sync files. So it's going to allow you to translate the information. And the reason why I'm doing this is because the thing that I'm trying to do now is to create the things from code, from C++ code, but I don't necessarily want to put everything on the same class. So in order to create this bridge between classes, I think this is the best way I found. There is other ways to do it, but I think this way is probably the easiest and best that I found so far. So unless it doesn't work for whatever reason, I might have to change, but if it does work like this, then I'm probably gonna keep with this way. The other slight change that I said that might be possible is that instead of making this the direct child of the root, what you can do is just make it as the root as well. So you can make this as the root node, which I thought about, like you can create a class called root node and then inherit from node, and then always make that class the root of the scene. But then this, actually, it might be better that way because it might be easier. So I might try to do that as well. But the only downside is that is like thinking about how the state is going to be changed from the code and how to make sure that you always have the class state. But I'm going to talk about this later because it involves other things. But basically what I'm doing here is just I create this class, then I add this class as a child of the scene root directly, like I said. Then I'm creating these two other classes and I'm adding them to the root node, and I'm trying to connect this slider here with the other one. So when the value of one of the sliders changes, the other one changes. And the way that you do it is by calling the subscribe, which is the function that I explained there. Then here I'm getting the node name of the slider, passing the which signal I want to connect to, and getting the node name of the target, and passing which callback function, the name of the callback function that I want to run after this signal is emitted. Then it goes over this functionality, which is just explained. It changes the state of the signal serializer, which contains the dictionaries that are subscribed as properties of the class. And then the main function that is going to run is this connect signal here. No, is the connect all signals. Initially, I was doing connect signal because I was running the function every time the signal, one of the nodes is added. One of the nodes is added. And then for that reason, I thought that I needed to check for both situations when the target is saved as a source on the dictionary of the class, and also when it's saved as a source, because I wouldn't be able to be 100% sure of the order that the nodes are connected. So I need to make sure that the connection is made, regardless of the order. And this is the reason why I made the check here to see if the current node being added is the source or the target, if the connection exists. But I'm going to explain this one because it's probably the one that I'm going to use. So this one runs after the full tree is initialized, which is on the notification ready, after the notification ready event. So I'm just checking to see if there are connections that were subscribed, which is mapped here. So source to target names mapping, which is the dictionary. And also to check if the root node was initialized. So in this case, I'm getting the owner, which is supposed to be the root of the scene. So I'm initializing here after the node enters the tree. So if both of these things are true, then it means that the class has signals on its state. Then the keys function is a function from the dictionary, which allows you to get all the keys. So I'm basically getting all the source names for the connections. Then I'm looping over the source names, and the current one is going to be the source. And the way that you get the target is just the target is going to be the value for the key on the dictionary, on this dictionary here. So you get the source, then you get the target using the source name. So you got both the source and the target name. Then you can use this find child function from the root node to get the actual node pointer from its name, because this one is going to look for all the children of the root node and is going to try to find the source node here. Well, the other thing that I just realized is that it's probably better to check to see if the source and the node exists. So I'm probably going to do that, but yeah. So then after you have the two names and you have the nodes, then use the other dictionary, which is based on the source name. This one is going to map the vector of dictionaries with the source name. So the source name is the key, and the value is a vector of dictionaries, where each dictionary contains a pair of the signal name to the function callback name. So you're going to loop over the vector, it has to be vector variance, so Godot can translate the information. So each one of these is going to be a connection. So the first key of this dictionary is going to be the signal name, and the value of that signal name is going to be the callback name. And this is what I mean that I had to use another callable, and luckily they provide this callable here. So there's two ways to initialize the callable you pass through the connect. The two main ways. One is by using the callable underscore MP macro, which allows you to create a callable from another custom callable. So that store the information that way, or it allows you to just pass the names. So the name of the node you're connecting to and the name of the callback function. And I'm going to explain how they do the function call there. And then here is the signal name, also that I'm saving there, and the source node that I got from the name there. So this basically creates the connection of all the signals that were subscribed before the tree was fully ready. And then after I do the connections, I just update the state of this to flag that the connections were made, because this is used on the disconnect, because obviously I don't want to disconnect two signals. I don't want to disconnect try to disconnect a signal that was already disconnected. So in this class here, after I do all these checks to see if the signals exist, I also check to see if they are connected or not. And if the nodes exist, and if they are, if all these things are true, then I disconnect all the signals here. Hey, what's up? And it's fine to disconnect all the signals, because this function is only gonna run after the node was removed from the tree. So if the node was removed, it means that the function pointer, the node pointer is not going to exist anymore. So you don't want the signal to be called from a null pointer. So you have to disconnect all the signals for that node. So basically works, and then here flag is false again, in case I want to connect again. And the reason why I don't remove them from the dictionaries of the class is because the point of the class is to cache the signals. So if you removed, then whatever signals were subscribed would depend on what happened in the function, in the sync tree state, which is not very good, because then it would defeat the purpose of caching them from the code here. It would defeat the point of creating them from the code. So it wouldn't be very good. So that way the class state is always the same. It just changes the connection disconnection based on the runtime. The purpose of the class state is so you're able to cache the signal connections. And the way that this callable here works, so the way you're able to use the function name to store the callback, is that they're going to use, so they store the method here, but when the signal is emitted, they're going to use the states of, they're going to use method bind to keep or to cache the callback function. And then the method, the way that they're actually going to call the callback function is using a method on the method bind function, which is the call method, which is going to allow them to use variants to actually do the function callback. It's very complicated. This part of the signals I didn't like that much because it seems overly complicated, but it works, so I'm gonna leave it like this. And this is basically what's gonna happen there after you connect. You pass the callable, and then it's gonna store as a callable, and then when it emits the signal, then it's gonna use the information instead of the callable to do the callback function, which is going to be based on a method bind. So the moment that it emits the signal, you pass the signal name and you pass the arguments as a template here. Then this does the implicit conversion from the templated type here. So you're emitting the signal, you're passing the name of the signal as a string, and then you're passing whatever arguments the callback function is going to need. Or we will receive, because you're transferring information from the function that emitted the signal and from the callback function that is going to run based on whatever is to say. So the example of the slider, this would be a float value, for example, that contains the value of the slider. So here would be 31, for example. So it's passing as 31, and the way that it's able to do the conversion as a float is by doing this equal sign here, because the parent class is going to overload the operator for floats, which allows it to determine what happens if you have an initialization for the float type. It's basically implicitly converting to a variant. They're on the equal assignment. And then it's going to call this other function here. And this is the function that is actually going to do the callback from the callable that you subscribed on the class. So it basically happens here. This is doing the copy from the callable, which means it's going to call from here because it's not a custom callable, the way that it initialized there, which means it's going to call from the object and guess the object based on the instance that was stored there. And the method is going to be the string name of the function. I didn't look into this. I know it works because I tested there, But I looked into the conversion from string name to the function on the add property macro, because add property macro works in the same way. So it looks like it gets the method based on the class, which is the method bind, and then does a call based on the method bind. That's this. So basically, this conversion, I think, is easier to understand from the function name to the actual function by looking at the add property macro. So the way that this works is you create this class, is a macro, and you're going to pass the information here, and this is going to subscribe the property of the class on class DB. And then the names you pass here as the second and fourth argument are the setters and getters for that property, so that the editor is able to update the property. So it's basically allowing you to determine whatever is going to happen when you change the property here. So for example, if you change here for 40, you're going to see that there is a function call here. And the way you're able to set this is with the setters and getters you register on the class using that property macro. So the editor is basically using the setters and getters you register here, and you register them with a string name. So this calls this function here. So you can see that the setters and getters are this string that Godot creates. It's a static C string, I think. It's basically a string pointer for C, I think, based on a class that they create to make that happen. The get class static is going to get the name of the class, pretty sure. And it's going to get the name of the current type that is being subscribed. So in this case, it would be signal serializer as a string name, the type. And the type is, this class here is defined on the macro, the GD class macro that you have to call there on each function. So this macro here, this is going to define a function that is the get class static name, or whatever function it is there, which is going to allow Godot to return the name of the class as a string name, because it uses a token, this token here, to define the function. Let's look here. So it's basically this function here. So it creates a string based on the token you pass here, which is the class here. So it's converting this as a string name. So the moment that you call, that Godot calls here is basically converting the name of the type of the class into a string name and then passing that to the function. With the property, which is the class there, property info class that is going to hold the state for the class. So property info, the string name of the setters and getters, and the name of the class. So inside of this function, you can understand how Godot does how does it hold the state, how does it store the state on the class that it's going to use to manage this translation of states from. It's basically allowing you to serialize the information of the class into the sync file, so do the read and write operation based on these other classes here from the string names that you pass here. So it uses, the classes is a global object that is going to contain all types that Godot has, which it knows based on the GD register class macro that I showed before, which is the class you use to register the types on the class DB. They're basically going to put the types inside of this global object here. And this global object holds the information for all the classes. So based on the name, you can get the type, which is this class info that holds the information for the class. And then here is where it does a conversion from string name to method. It's basically a method bind. So it uses the string of the function name and the class type, the string of the class, and then uses this function from class DB to turn that into a method bind class. And the method bind is the one that holds the states of the function. So the types, how many arguments, the types of the arguments and stuff like that the function needs to run. And it's using this class DB to do that. So the class DB, you're going to get the class info class from the class DB by passing the name of the class. And this class info has as one of its member or properties, one of its properties, the method map, which is a collection of method binds, which are basically holding the state of the functions of the class. So a hash map that contains the name of the function and the method bind, probably, which is the class that is going to manage the state of the function. Yeah, so it gets the pointer. This is the name of the function, string name of the function, gets the pointer, which is the method bind for the function, and returns that. And then it's going to use this method bind to store on the property info. So this method bind here is basically holding the state of the callback function that is going to be run, and it builds from the string name by using this method here, and then it puts on the property info. Yeah, it is putting on the class B type there with another member variable that keeps track of setters and getters for each property. So here is mapping the name of the property with its setters and getters, which is this class here, which is going to contain the method bind, which is the class that manages the state for the function callback. And the way that I think that is probably gonna run on when you emit the signal or when you update the property on the editor is by calling a method from the method bind here, which happens on another function here, which I think is set property. This one is the one that allows you to get all the properties for a class based on its name, just its type, which is basically the same logic, just doing the other process of accessing the value of the check, which is the type of the class, and the property list that it has, which is all the properties that you subscribed using the macro there. And it's going to put them on a list. So this is the main function that Godot uses on the editor to retrieve all the properties of a class. So it does based on its name, because on the editor here is going to display here based on the state of this doc that it uses. And then the name is going to be basically the name of the cell that it has here. So from the name of the cell, it is able to get the type of the class. Or, not really sure. Maybe it's not from the name of the cell, but I think it uses the name of the cell to get the type of the class, which is going to be a string name. And then from the string name, it allows it to get the properties by using this function here and putting them on a list. And then it uses that to read and write from the sync file, because it has access to all the properties. But the one that I think is the set property here. I think so. I'm pretty sure that this is the function that is going to run after you change a value. So for example, on this one, if you put 40 here, it's going to run the set property for the range class with whatever it was subscribed on the range. So yeah, so for example here, one of the values of the class, like this is all the values of the range there that are exposed here. So whatever function that they put here, the names are going to be the ones that run after you change a value there. So in this case would be this function here. And the way that it does that is on this function here. And it's going to do the same thing. Basically, it gets the type from the class B. And then with this type, it's going to get the method bind of the class info, which is the class that is going to go from the method map, which is mapping the name of the function with the method bind class, which is basically this thing here, which is the thing that I just showed there. This is the class that has the setters and getters that saves when you call add property. So it's getting that class based on the name of the property that you set it there. And this is the one that contains the property info that I showed there. And this is basically going to be the set pointer. So this value here is the method bind that it was created there on this function here. It's basically this value here, because remember it was set here. So the set pointer on this one is used when you set the value on this function here is basically the same. So as far as I understand, this is going to be method bind, I think. Yeah, method bind. And the method bind is the thing that has the function that is going to actually call the callback function there. And this is a function of a variant. This part is kind of confusing because this function is not explicitly defined on the method bind. It's defined as a virtual function. So I think what's happening is that at runtime, Godot's figuring out that the actual function that it's going to run is the function from the variant and not from the method bind. But it is declared on the method bind as a virtual function. And then depending on what kind of property it is and what kind of variant it is, depending on what kind of property it is, I think it's always going to call the variant function. But I'm not really sure on how the relationship works yet. But obviously it makes sense that it's going to call the variant function, because the variant is the one that is going to do the translation of the types, depending on what kind of property it is. So I think that's pretty much it that I wanted to talk about when it comes to signal serialization. And it seems to be working now. So based on the code that this scene I'm creating from code there is the code that I showed there. And this is the class that serializes the signals. And you can see here, this is the part that I said that it might be possible to make it easier or to make it better, so that it's easier to change here the connection of signals. But I think that this is the nice thing of this class, is that all the signals are done based on the state of the class, and the only thing you need is the string names. So 4 different string names that are gonna create the connection of the signals from that string name. And then the variations of stuff you can do is based on what data structures you use to create the connections, to change the state of the class that are gonna create the connections from the 4 different strings. So this allows you to create a connection of signal on any node of the tree just by having these 4 string names. And at any time as well, like you don't need to have direct access to the pointers of the classes to create the signal, which is usually what's done. So this allows you to have more flexibility on when you connect signals. And this is the function here. So you can see that it is declared as a virtual function and doesn't have a definition on method bind. So this part, I'm not 100% sure how it works. So maybe I was going to say that the class there that is used inherits from method bind, but I don't think that's the case. It's just a member variable. So I'm not really sure how this conversion is done. It might be from because on the variant class, they declare and define a bunch of macros and other structs that are helper data structures like the data structures that help convert the types using the variant class. So, and this part is extremely confusing to understand. So assume it's something along the way that when you subscribe the classes here, they're going to be saved on method bind, and then at the moment on runtime, at the moment it calls the call function there, that is actually going to do the callback. Is actually going to run the callback function. It's going to run that function from the variant, and the method bind just declares the type here. It's like a lot of stuff to explain, but hopefully this is understandable. Maybe we should stop streaming now and come back later to work on the other stuff, because that way I leave all the signal explanation on its own stream. I think I'm probably gonna do that. So the way that it's working here, it's kind of weird. There might be an issue with the initial value here. But this, I think it has to do with the way that I'm setting up there, because I'm just using these ones to test if this was going to work or not. But you can see here that as I change the value of one, it changes the value of the other, which is being done with the normal signal there. And this is the stuff that I wanted to change. So if I do the connection normally without using the serializer class, it does the connection at the moment I run the code, but it doesn't save on the sync file. So on the editor, it works as if it doesn't have the connection. And that's obviously bad, because what I'm doing here is just like running this, building the entire thing from code. And this is the idea that I have. So I do the connections here, and then I just open them from the editor if I want to, because these ones, they create the tree on code. And then I have another function that is going to save the new tree state based on the root node through the file, through the same sync file again, which makes it change the sync. So I think that's pretty much it. So now what I have to do, I think I explained everything. It's probably confusing for people that don't know a lot of stuff, but there isn't a way to, because there's so much stuff that's dependent on other stuff, so it's kind of hard to explain everything. I want to clarify, but I'm not really sure if I'm going to spend the time to clarify how exactly. Maybe I think it probably might be a good idea to go over with the debugger, and then I can step over this and I can put the breakpoints on this thing here to see what exactly is going on at the moment it calls this. But this is going to be the method bind there. So how does it figure out that this call should be from the variant class? It might be on the initialization of the constructor. Oh, that doesn't make sense. Why? So what I have to do now is something weird that I don't understand very well. But what I'm thinking about doing now is I'm just gonna leave this part like this, then fix this thing on the that I have to fix on the headless code. So the headless code is the code that I'm creating to create the whole thing from scratch. And on the previous streams that I did, I basically was figuring out this while live streaming. But basically I have this file here now that it is related to one of the projects that I'm using to test there. And this is the main entry point of the whole project that is going to run. So the idea is to execute the command from the command line here, which is basically this one. So usually if you want to run a project on the editor, I think, yeah, if you want to run directly on the editor, the project, and skip the project manager, you call the executable from Godot, then you pass /e and you pass /path, and then here you put the path of the project you want. Then Godot is going to build the project based on this file here, just the project.godot file. And it has a project settings class, which is the one that is used to manage the project settings, obviously, like it says. So it gets the state from this file, the project Godot. And then it opens the editor directly without opening the project manager. And it's basically running the executable for the editor GUI for that project. And what I did is basically change done some slight changes so that instead of running the editor, it doesn't run anything. It just runs the first frame, but without opening the window or anything like that. And then it runs the code that I put there as an entry point. And the code that I put is going to select, is going to run a function that is going to select which kind of project is going to run based on the path you put here, which is going to be directly is going to be equal to the path you put here or the folder. So the name of the folder is the name of the project, and then it selects which kind of function is going to run based on that. And the name of this function is the same pattern where you always put change, then the name of the project in the middle, and then underscore project as well. So basically this is the entry points that I have there, and this is getting all the root nodes for the project, which are basically directly correlated with scenes. So each scene is basically a node, root node, and use package scene to read and write from the scene files. So I extract the root nodes from the package scenes in the beginning on the setup of this. So basically this is a map that contains all the root nodes with the scene path. So I map the path of the scene to the root node. Then I loop over them and I'm checking to see what scene it is from the project. And then for each scene, I'm going to put in a specific function that receives the root node, the scene, and then from the root node, it changes the state of the scene. So I'm changing the state of the root node, and this will allow me, hopefully, to create the entire scene from code, or create parts of the scene from code if I want to. Then later on, it's going to save there on another function. So the problem that I have now, so one of the problems was this signal serialization, because I wanted to connect signals, but then if you connect normally, it doesn't cache through the scene file. So I think that for now, this seems to be solved on the simple example. But the other problem that I have here is that the way that I'm adding the child node here, the way that I'm preventing the same node to be added twice to the scene every time that I run the code, is by creating a hash set that is updated at the time that I extract the scene state from the scene file. So from the scene file, I get a scene file and I traverse all the tree and I put all the names of the nodes on this hash set, and each node has to be unique. And I'm creating a pattern to save the nodes, so I can differentiate the nodes created from code and the ones created from the GUI. But regardless of where you create, all the nodes have a unique name, because it's just basically the way that Godot works because of the caching mechanism. So the differentiation comes from the name, which I'm doing here. So I have this other static, which is a global integer that keeps track of it makes sure that each name is going to be unique. And this is the part that has like a lot of nuance, because it's kind of tricky and I'm not really sure. And this is the part that I'm going to have to spend much time thinking about. Because you can imagine, like, for example, one of the issues that in the way that I'm doing here is that the order in which I add the nodes should always be the same because of this global variable here. So if I have the same code, which would create the same state, but I change the moment where I initialize one with the other, is going to mess up the state of the scene there. So this is one of the things that I have to change. The other thing that I have to change is that if I want to add a child node for a node that was already created with code, so I have the root of the scene, then I have a node that was created with code, and then I run I do some changes after I created the scene to add another node as a child of the node that was created from code. It doesn't allow me to do that because I'm checking here to see if the node already exists, and if it exists, I'm just returning the function. So I think in order to make this happen, what I have to do is, if the node already exists and I'm going to add a child to that node, what I need to do is I need to remove the parent of the tree and then add a new parent to the tree and then add the child to the new parent. Because the other thing that is problematic is that every time that I run the code, I might want to change the state of the nodes that were already part of the scene. And this is the issue. Because if I do it this way, then it never changes the state after the first time that I run the code, because it's always going to return before. And I'm not really sure how to do this. This is like very challenging. Now, obviously, the easiest thing that I can do is just the stuff that I said, but even then, I'm not really sure, because you can imagine if you have a node that has a lot of children, then if you're going to remove that node, it's going to be very hard. You're going to have to think about how to restructure the scene. So And it's kind of annoying because I think it's gonna be, I have to create an algorithm that checks to see how many children, how many direct children the node has, then reassign the pointer of the children, like reassign the pattern, the parent of the children to the other node, then switch, then reassign again. It seems very annoying. So I'm trying to think about which ways I can change this so that it works. And once I figure this out, that I have a way to add the nodes programmatically, then what I can do, then what I'm gonna do is go back to this thing here and then create like a more complex, probably just gonna create more of these classes or use other classes from Godot to create like a bigger scene tree. See, I think I'm gonna do the editor directly actually. So what I'm thinking about doing eventually is just getting the code that makes up the editor node, then copying that and putting that because I want to study the layout from the editor. So that's probably what I'm gonna do. Then instead of creating the signals the way that they create, I use this class here. And instead of adding the child nodes in the way that is usually done, I'm just gonna use this function that I created. So this is the idea, to create the whole editor layout from the code. So then I can open the scene from the editor and study how it works. Then do experiments to change the state from the code or from the editor and see what happens. I think I'm gonna stop here. I might come back today to continue this because I think it's better to just leave one string explaining everything related to signal serialization. So next time, if I come back today, next time, I'm either gonna take a break and then come back now, and then try to think about how to solve this headless code stuff. But if I don't do that, then I'm just gonna continue to develop. Not sure what point I'm gonna be at, but I'm gonna continue developing this to be able to generate entire scenes and layouts from code, from source code. So